1, 2, 3. Yeah, yay. Okay. So thank you very much for attending. We're going to be talking about transactions in Django, a endlessly fascinating topic. So, of course, if you saw it in the program, your first reaction would be about transactions. He's going to talk about transactions. You know, it's like talking about lint. You know, because you do a begin and you do some stuff, and you do a commit, and maybe you do a rollback if you're feel up for it. And now it's lunchtime. Okay, talk ed done. Thank you for attending. Okay, not. There's a little more than that. I've been working with Django since 2007, and transaction management has kind of been my life. In fact, I joined PGX specifically to help a client who is having transaction problems, so I have a deep personal association with transactions. And to this day, transaction management in Django is something that we frequently are called upon to help fix for clients. So I'm going to save you a bunch of money so you don't have to hire us. Wait, I thought I was CFO of this company. Anyway, and there's also some fun features that people don't take full advantage of that are really easy to use in Django that can get you some kind of cool stuff when you're working with it. Now, first, this is a caveat. Suppose you wanted to paint your house. And so one of the things you need to decide is, what color will this be? So you walk into the paint store and you're standing in front of the chips thinking, And the helpful salesman comes up to you and says, well, what can I help you? And you say, I want to paint my house. And he says, certainly, what color would you like? And you look at him with this slightly disdainful expression. You say, color? Well, all of them, of course. I'm color agnostic. This is kind of how I feel about database agnosticism, is that there are if you're a paint manufacturer, carrying the full line makes a lot of sense. If you are trying to paint your house, it's time to make a decision on which database to use. And thus, this is not a database agnostic talk. If nothing else, the name of my company should be kind of a tip-off as a bias here. But PostgreSQL does have very sophisticated transaction management and some interesting quirks. And we're going to focus on those guys. There are some goodies here you can get out for MySQL too. So just if but the depths of MySQL knowledge will be something that you will never worry about drowning in from this talk. So, okay, what is a transaction? I mean, conceptually, what is a transaction? The spec goes on forever, and who cares? Whoever reads the SQL spec. Anyway, certainly the database vendors don't. Rimshot. It's a set of SQL statements that should be applied atomically. In the case of a session failure, which could be a disconnect, a server crash, you explicitly roll back, you get an error and it makes you roll back, the database returns the same state as it was before the transaction. So nothing was applied inside that transaction. That's it. So whole thing's applied or none. This is why we call them, that's why we call them atomic, because back when databases were invented in 1878, people thought atoms were indivisible or something, I don't know. But it's not just that. Because of the nature of transactionality in databases, a lot of database resources are allocated and released on transaction boundaries, and it's important to keep this in mind. The big one is locks. Locks tend to be, with one exception in PostgreSQL that we won't talk about because it's kind of an edge case, are all released when the transaction is released. And locks are an in-memory structure in Postgres. Some temporary tables are scoped to transaction boundaries, and some database settings. But the important thing to remember is that a long-running transaction can hold a lot of data inside of memory and can be a source of a lot of problems. The good news about them is, in Postgres at least, a single transaction contains an arbitrary amount of data change. How many people have Oracle experience? Just out of curiosity. How many people have ever overrun their rollback buffer? Yeah. You don't have a rollback buffer in Postgres, so you don't have to worry about that. It's very nice. You can't fill up a transaction in Postgres. There is no upper limit to how much data that can be changed. Commit and rollback are very fast operations in Postgres. Under normal circumstances, you can make commit really slow if you try hard, but so don't do that. One example of this is PG restore, which restores an entire database from backup. In serial mode, runs inside a single transaction, so the entire database is restored inside a single transaction. Therefore, we can conclude there is no real upper limit to how much data you can play with inside a transaction. Sessions and transactions have a relationship. So a session is always local to a single, transaction, excuse me, is always local to a single session. A session is a database connection for all practical purposes. So when you connect, you get a session. Each session can have exactly one transaction running on it at the same time, unless you're going crazy with things like two-phase commit and prepared transactions, which you probably aren't. So Django transactions, you look at the transaction code in Django, and clearly there's some history there. There was things on top of things. Fortunately, the situation's gotten much better very recently. So in the beginning, the very first behavior that Django had was every time you did a statement, it wrapped it inside a transaction. That's what it did. So you did an update, there was a begin and end on either side of it. And it did it explicitly. Reading the docs, I think they were trying to get behavior that the SQL spec specified, I think, out of this. Not 100% sure what was going on here. And then, everybody with database experience looked at this and they said, and they looked upon this and said, huh? Because it's really easy to get database inconsistencies this way, because you do an update and then you do a second update and there's a failure between them and the first update's been applied and the second one hasn't, except there was some kind of foreign key relationship and now you're in trouble. Furthermore, the begin and end isn't always required, since a single statement in Postgres is always atomic. So you weren't actually getting anything for that. So OK, that kind of didn't work. And then came along transaction middleware, which I would say for most of Django's run has been pretty much how people have managed transactions in the 90% case. It was a layer of middleware that creates a new transaction for each web request. This has a lot of nice stuff about it. For one thing, it means each view function runs atomically, which for a web developer kind of makes conceptual sense. I mean, the view function is what you write. And it means if the view function failed for any reason or an exception escaped from it or something like that, you knew that there was going to be a rollback for the whole thing. And that was pretty cool. And it's kind of hard to mess up, which is really nice. You know that the whole thing is going to do its thing. But it wasn't perfect. The first problem was there was no fine-grained transaction control. Either the whole view function was applied or it wasn't, and that's not always the behavior you want. The middleware, and unfortunately the decorators picked this up, is that if it thought there were no data modifying operations, it did a rollback. Which was weird, because if you did any kind of raw SQL and you spend the rest of your life trying to debug why it wasn't being applied, and then you saw the rollback back there. And the problem is that to fix that required some heavily, this is not a supported API style hackery to set the dirty bit on the transaction. This was the bad one, and this is actually what got me my job at PGX. There have been mysterious idling transaction sessions that plague Django applications when the transaction was not explicitly committed. It's still not 100% clear to me what the source of these is, but what was happening was the session was being left open with a transaction open. That's very bad inside of Postgres. So this was generally but we ran with this for a while. But there were also these decorators, commit on success, commit manually, and auto commit, which they could use either decorators or context managers. And this was very nice because it gave you fine-grained control. You could wrap a single bit of work inside of each one of these, and if an exception escaped from it, you get a rollback. Otherwise, it would commit. And that was pretty nice. Very nice use of the decorator context manager model, certainly. And so yes, and if an exception got out of it, which you could catch, of course, you got a rollback. Sadly, it still wasn't perfect. It still had the raw SQL issue. So if you did something that modified the database that wasn't through the ORM, it didn't know about it, would issue the rollback, so you had to do some hackery. It still created this pointless transaction around read-only operations, which is not a big deal, but every little statement counts. And they couldn't be nested in reasonable ways, which doesn't sound that bad until you start writing code inside of code, and the outer code doesn't know whether or not it's being invoked inside of a transaction block or not. And so what would happen is this first level of code would open a transaction, the lower level code would do its stuff, and then issue a commit, which would commit the whole thing, including the caller. Very bad, kind of messy. So I wrote this thing called Exact, which was my attempt to fix the problem. It was PostgreSQL only, and it required setting auto-commit inside of settings PY. It handled the raw SQL problem by just saying, well, you open the transaction, we're going to assume you modified the database. So but it was a hack, but it was a pretty sensible one. And using PostgreSQL save points, you could nest it so that an inner transaction could roll back while the outer transaction could still commit. So that was pretty nice. But there's always a problem, isn't there? It's PostgreSQL only. It was sort of hacky. It worked, but it wasn't great. The biggest hacky part was it didn't really play all that well with the existing decorators because it was an add-on that was not in core. So you could still get this problem of the whole transaction committing because something low-level called used one of the built-in decorators. So finally, in 1.6, we got Atomic, which is the right solution now. Thanks to Amber Cognizant for implementing it. The nice part about it is it works to the extent that the database supports it on all the backends, so that's cool. And it's reasonably nestable. And it's also in core, so it has fewer weird interactions with the other techniques. But, oh, nothing. Cool. If you don't use Atomic already, just use it, really. Just stop now, pull up your laptop, I'll wait. Everyone converted? Great. And the nice part about it is if you were using Exact already, you just search and replace Exact for Atomic and you're done. Exact had a feature called the rollback exception, which Python programmers hated about it. It was an exception that you could throw from within an Exact block that would be swallowed by Exact, do the rollback and escape, because frequently you're down deep inside code and go, I'm crazy, I'm so confused. I just want to roll all this back, but keep on execution. It's easy to emulate, of course. You just wrap the Exact thing in your Atomic block inside of a transaction. So if you're using this, you have to do a little more coding, but it's not bad. So first lesson is, if you're not using Atomic already to manage your transactions, do that. Unless you're on 1.5 or earlier, in which case just use Exact, which means you have to use Postgres, but why is that a problem? OK, so now we know how to do the basics of transaction management. But you really, your transaction model is something you should think about when you're building a new application. Of course, the first reaction is like, oh God, do I have to worry about transaction management too on top of everything else? Yeah, sorry. Don't accept the default transaction management. Not accepting it, but actually thinking about what you're doing, it's not that hard, and you'll really get a nicer, much more database-friendly application out of it. And you can bring to bear some nicer features too. So the first thing to do is just use Atomic for everything. Django view function, because Django view functions tend to have this style. You read a bunch of stuff, you do some processing and error checking, then you write a bunch of stuff, and then you return maybe with a redirect. Not every view function in the world has this, but this pattern happens over and over and over again inside of Django. Fortunately, this is one that's very friendly for this kind of transaction model. So you bash all the writes together using Atomic around that write all the stuff. Sometimes there'll be multiple logical groups, things that don't have to be all committed together, that it's acceptable that if you fail, that this section is one logical bit of work and another one. So break those up. Use different Atomic groups for those. And remember that that in this model, the database state can change out from under you. If there are concurrent writers to that same bit of data, from the point you did all the reading to when you did the writing, the state of the database could change. So if you're doing things that demand that everything you wrote be exactly the same, you have to do something else, which we'll talk about. Always keep transactions short and to the point. Don't do long-running transactions. If you're doing heavy data crunching, don't do that with the transaction actually open, holding all those resources on the server. Especially don't call out to an external service with a transaction open. Don't call a web API. Don't send email. Don't do all of this. Don't do things that could take a theoretically unbounded amount of time. That's because you'll be holding lots of resources on the database you probably don't want to. And never, ever, ever, ever exit a view function with a transaction open. Fortunately, with Atomic, because of the syntax, it's almost impossible to do that minus some kind of screwy bug. But if you're using your own manual transaction management or something like that, just never, ever do that. This also means you basically can't use transaction middleware, which is good because you shouldn't be anymore. Now, one of the things when I get into this discussion about not exiting a view function, they say, but the system should just handle that. Isn't it going to close the session and I'll get a rollback and I don't have to worry about it? In theory, that is absolutely correct. And if you look at the code, it's implemented that way. Don't rely on it. At least 1.6, Django is notorious for not actually doing that rollback and leaving the session open with the transaction open. This is a very, very common complaint. Search for Django idle in transaction sometime on Google and see what you get. So always manually open and close your transactions. Just do it. So remember how I said, you do a bunch of reads, and then somebody comes along and messes with your data and you do a bunch of writes? And maybe you're crazy now. Now you're not very happy because those writes changed the model of the database that you had? So who knows what a transaction isolation mode is? Who has ever used one that's not the default? OK, certainly worth talking about. So there's a basic question in a database, which is, if another transaction commits while your session has a transaction open, can you see those changes? So what's the answer? In PostgreSQL, by default, if you accept all the defaults, the answer is yes, you can see the changes. In MySQL, actually, the answer is different. It's no. And this is a very basic approach to how concurrency control works in databases. The way we decide if that answer is yes or no is what's called the isolation mode. The spec defines 4, he said, holding up 5 fingers. Notice the slash through read uncommitted. Which are read uncommitted, read committed, repeatable read, and serializable. These are colloquially stronger as they go down the list. So this is the strongest, that's the weakest. Read uncommitted, which is in the spec. In a I'm going to talk about this just to kind of dispose of it, which is you can see, you don't just see work other people have committed, but you see other work that other people haven't committed yet. Postgres doesn't support this. MySQL actually does support it. The problem is you read the documentation and you realize the results are actually completely undefined. You kind of see stuff that was done. But you aren't actually guaranteed that you see all the work other people have done, just some of it. So needless to say, you shouldn't ever use this. I do get requests sometimes from clients saying, well, how can I make this work? And the answer is, build your application in a better way, thank you. Sometimes put more nicely than that. So the default in Postgres is read committed, which each transaction can see the changes it's made and any changes from any other transactions that have committed before that point. So the database will be changing out from under you as it's working if other transactions are doing. So 2 selects in a row inside your transaction can return different results. Now I'm curious, answer honestly, how many people are surprised by this statement? OK, a couple, yeah. Because web developers, I've noticed, tend to kind of think that within a transaction the database is invariant, that they're the only people with their fingers on it. And that's not true in read committed mode. Note that this is, of course, only for successful transactions. If something else aborts, or rolls back, you don't see it. It's as if it never happened. This is the default in Postgres unless you change it. You can change it in PostgreSQL.conf. I don't think anybody ever does. It's very straightforward. It minimizes unexpected errors. The behavior it's nice and clean. You can't rely, though, on a consistent snapshot of the database. You can't do a bunch of reads and then do another bunch of reads and expect the data will be exactly the same in the presence of other people, of other sessions working on the data. So 2 selects in a row can produce different results here. So you can crank it up, though, to repeatable read. In this mode, the transaction only sees changes the transaction itself has made. So any other worker will not affect your snapshot of the database. Well, that's kind of cool. It's like you have this fork of the database that's all yours. No one can touch it. It has a perfectly, asterisk, consistent snapshot of the database to play with. That's pretty cool. Asterisk. Some restrictions apply. Offer not valid in the presence of a truncate statement. If you ever use truncate in Postgres, truncate does not follow the rules completely. You have to really work to see an inconsistent view of the database, even in the case of truncate. there's this long note that everybody who reads it totally freaks out as if truncate's going to corrupt their database or something. This is what it means. That repeatable read, for reasons that we can talk about in a hallway track, it's not important now, doesn't fully support repeatable read mode. This is the more important one, though. The offer doesn't include automatic merging of conflicting changes to the database. What did you just say, Pettus? Suppose we did this. We do a begin, and then we do an update, and then and a commit. This is transaction 1. At the same time, transaction 2 is coming along, and it updates the same row with a different value. And commits. OK. Now, these are both running in repeatable read mode. So we get two different, so each one has its own view of the database. What do we do? What's the state of the database down here? PostgreSQL doesn't try to merge these changes in any way. It doesn't try to figure out which one's the winning tuple. The second transaction, that is the one later in time that tries to do the update, will block, waiting for the first one to commit or roll back. If it rolls back, no problem. It never happens, so it just applies the change and keeps on going. But if it commits, you get an error. An error comes out of your connection saying serialization failure. So you have to be prepared for this in repeatable read mode. You can get these errors. So what do we do when we get one of these errors? Well, you can just retry the transaction, stick it in a loop, and just do it again. Because the next time it'll probably succeed because there probably won't be that conflict on that particular row. Unless, of course, there's some kind of concurrency pathology. But you should probably know. If this is a good thing to flush this out if it happens. One thing to remember, though, this is a flavor of race condition. Two things are trying to nail the same tuple at the same time. So you should probably understand pretty well why you got that error. It may be benign. It may just be that in that particular workload, different things are updating the system repeatedly. Like you have a singleton record with a counter in it, and lots of different things are pounding on it. I hope you're not doing that, but that's what is one case that this happens. So you can actually just build this. Unfortunately, one thing about context managers is there's no way for them to rerun the thing they're the context of. So you can't build this as a context manager, which is a shame because it would be really nice. So you just build this little loop. You try it, do your thing. If you get the exception, the serialization failure, you just keep going. Otherwise, you propagate the exception because it's something else. And if you got through the whole thing, you break. Problem solved. So when should you use repeatable read? Well, when you need it. When you need this consistent view of the database. Here's one example, which is, suppose you have a big queue of work items you're processing, like jobs. And you select a bunch of them, process them, and then you delete them. And you delete them all on the basis of a timestamp, or something like that. If you're not in repeatable read mode, what could happen is you do the select, process them all, a bunch of new ones get added to the end, and you delete those too, and you've lost them. So repeatable read, you don't have to worry about that. You know that that list isn't going to change. You could solve this problem with select for update, but then you get blocking that you may not want. Repeatable read effectively gives you optimistic concurrency control on this. If you probably aren't going to run into any conflicts, you're OK. Well, but that's not the strongest one we have. As of 9.1, we have serializable. Because repeatable read is not true serializability. And what we mean by true serializability is two transactions which mean no matter how they're run in parallel, you sort of move them up and down, trying to line them up in freaky ways, there's always a result that means either one ran first and the other one ran, or the second one first and the other one ran. There's no third result that it could get. So serializable transactions are ones that always could have run in some serial order. It doesn't have to be both. It just has to be one. And as of 9.1, we have this. This is kind of a funny thing in the documentation, because there was this, before 9.1 in the Postgres documentation, there was this long thing explaining why this serializable mode, true serializability, was impossible in Postgres. And then someone published a paper showing how to do it. And now that same section of the documentation explains how to do it. So this is why, don't trust forward-looking statements in documentation. But the question is, OK, well, this makes no sense at all to me. How could this ever be a problem? Well, here's an example. We have a doctor on-call scheduling system. The business rule is only one doctor can be on call at a time. don't bike shed the example. This is obviously a calculated one. If more than one is on call, take one of them off randomly. Doesn't matter which one, it just has to be one. This is subject to a problem called write skew. So suppose we're doing that thing, and we do begin and select. Now we're in repeatable read mode, so nothing will change under us in the database. So we know this number will not change until a commit. So we're good there. We select a count, and both of these come back with 2. Okay, so we know, oops, okay, we have to take one off. Yeah, it's doing that again. Okay. And so we do this. One takes Dr. ID 1 off, the other one takes ID Dr. 2 off, commits. There's absolutely no conflict here. And now we have 0 doctors on call. And this is a case where repeatable read doesn't give you the right result, because you never touch the same rows. You never write to the same rows to cause that conflict, but you still end up with a bad result from a business rules point of view. So that's not good. So how do we fix that? Well, we turn on serializable. In this case, T2 would get a serialization failure, because serializable mode doesn't just keep track of what you've written, but it also keeps track of what you've read. And if if you do something that will cause the result of an earlier query to change, potentially, it's not perfect, it's pessimistic. So you can get false positives, but it's pretty good. You get the serialization failure message out of it. There's a lightweight graph and lock mechanism. There's a paper by Kevin Grittner, is one of the authors, that describes how this works, if you're curious. It's actually pretty easy to understand. I understood it, so anyone can. And what's nice about this is it lets you avoid all kinds of nasty full table locking. Because really the only other solution to this is you lock the whole darn table or something. And in high concurrency situations, that's death. So this is pretty nice. And you have to be running on Postgres 9.1 or later, but I hope everyone is at least that high up. Now, my advice now, especially if you're doing greenfield development, is use this mode. Use it as your default mode. Just turn it on in the defaults. Because it'll flush out some weird concurrency problems you didn't even know were there. And if you really need to, you can drop back into a lighter mode. And what's important is the performance hit is very, very small on this. It's actually very efficient. So for most applications, just switch it on and see what kind of fail, at least on your staging system, and see what kind of errors you get. Because it could surprise you. It's a little bit like running with assertions on in the database and seeing what flies out. The question is, okay, we get one of these serialization failures. What should we do? So should we consider this an error, or should we just retry the failing transaction? That's an interesting question, and one that doesn't really have a general answer. In development, you should certainly flag them, at least log them and track down, so why the heck did we get that? Often, you'll discover that you had some bad assumption about the way you were using the database. Specifically, something like you were relying on data not changing under you in a way that repeatable read would not notice, but serializable did. But you will find times that you go, okay, this just happened to be a concurrency issue. One of these concurrency issues, we touched the same thing at the same time, and those you can stick in a loop and retry. You can turn it on by default for your Django application with an option. You can also turn it on for the whole database if that's what you want to do, as with the PostgreSQL.conf setting. I need to figure out why my slides do this. There are a couple of exceptions which are really edge cases. Who's using PostGIS? Okay, if you're using PostGIS and you're using heavy gist and gin indexes in that, or you have nested atomic decorators, not just a single level, but nested, so it's using save points, not just transactions, with heavy write volumes inside the inner transaction. Like I said, definitely an edge case. Serializable does have some quirks right now that make it kind of high overhead in those situations. So you may not want to turn this on by default if you're in one of these two cases. These are, needless to say, fairly rare. This one's relatively common. This one's really rare. Let's talk about deadlocks, because deadlocks really are kind of a serialization failure, conceptually. So first, a deadlock doesn't mean just the database is slow. I'll get a call from a client that says, our database is deadlocking. And I'll say, oh, that sounds really bad. What's happening? Queries are taking 200 milliseconds. Huh? That's a little bit like saying, I hit a tree. Oh, that's bad. How do you know? Well, I ran out of gas. They're fundamentally different things. So please, just use the right terms. Thank you. A deadlock is when two transactions can never have their mutual lock request granted because of a cycle. That's what a deadlock means. So a deadlock isn't just it's slow. A deadlock is it would wait forever. There is no exit condition except the database crashing. So for example, transaction 1 needs a lock on some resource A. A could be a table. It could be just one row in that table. T2 needs a lock on B. But T1's holding a lock on B and T2 on A, so they can never be granted. There is no exit from this. Something just has to something has to give. PostgreSQL does have a deadlock detector because every real database has to have one. And the way it solves this problem is it picks one transaction random and just kills it, and the other one goes forward. There's all sorts of, and it generates an error in the log, of course, that this happened, and the client gets an error back. And so the other transaction now can continue because when the victim transaction died, it released its locks. There are complex graphs that of these lock requests that can have cycles in them that Postgres can't detect, but those are actually quite rare. So it does happen, but it's very, very rare. To avoid them, always modify particular models in the same order. And if you're modifying both a child and parent table, walk up the hierarchy always because of the way Postgres requires locks on foreign keys. So if order depends on customer, modify order, then customer. This won't fix every deadlock problem, but it'll fix 90% of them. Most deadlock problems come from in different view functions, you're doing this stuff in different order, and those cycles start being created. And avoid frequently updated singleton rows. Always, 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 always. Another way you can help keep locking under control is it's often better to insert in a table and clean up later than update a single row over and over again. For example, keep a user login history or a user click history rather than a last login field, so you're pounding on the same row over and over again. Because insert, at least in Postgres, creates no row locking overhead at all, so you're much less likely to get a deadlock out of it. And the way Postgres implements an insert is as a insert update, insert delete pair anyway, so no big deal. So now that I've said all this, what have I said? Do this. Use the atomic decorator to cluster writes within each view function. Run in serializable mode by default, unless you just can't for some reason, but figure out why you can't, because I think that will be revealing. Always modify models in the same order and walk up inheritance hierarchies. And of course, use PostgreSQL. And of course, if none of this works, hire us. We know things you don't. And thank you very much.
Thank you very much, Christophe. OK, so we've got time for a few questions. If you want to file your way down to one of the two mics, we can get them sorted out while we're waiting for the madding crowd. OK, so you've explained transactions, and there are complexities in there, and there are things you have to know. A lot of people who are coming to Django, though, are coming from a background of no computer science background, and they're dealing with generally fairly small sites. Mm-hmm. Is this a case of something where you just got to take your medicine, learn how these things work, and go, or is it actually a perfectly acceptable thing to say, I'm just going to run in a non-transactional mode and just ignore this until I actually have size problems?
Depends on. It's an excellent question. And of course, being a database guy, my gut answer is, well, just do it, be good. But that's not real world for everybody. What I would do is, as you're reading your code, because everyone sits down and reads your code, and you're looking at your view function and go, I'm just going to draw a little red line after each dot save, and think, what if nothing else, everything after this didn't work? How bad would that be? And if the answer is, who cares? It's a blog. Then you're fine. But it's an excellent intellectual exercise to do that kind of what if thing. If you're building a site that you expect to scale to volume, just learn this stuff, because it will kill you if you don't. So it's a relatively low volume site. You're learning how to program all this stuff. You don't really want to become a database guy and I could certainly understand that feeling. Then it's okay to just think of it as an exercise of like, what if the blog entry went in, but I'm saving a comment, but I'm also saving the blog entry at the same time, and the blog entry got saved and the comment didn't. Who cares? It'll work out. That's fine. If you're trying to be the next big thing, though, learn this stuff, because it'll save you an expensive call to us.
You showed setting isolation level as a global setting. Is it possible with Django to set that on a per transaction, and is it a good idea?
It is completely possible to set it as to set it per transaction. Right now there's no sort of nice Django construct, connection dot isolation mode. You have to issue the raw SQL command within the atomic, within the scope of the transaction. But you can absolutely do that. You have to do it before the first time you do anything else to the database, because once it, in technical, to be ultra precise, once it creates a snapshot, you can't do that. Generally, the reason it creates a snapshot in most cases is when the first time you either read or write to the database. So you can do it, and it's a perfectly valid thing to do. For example, you may run in read committed most of the time, but there are times that you actually need that snapshot capability, and then you crank it up to repeatable, read, or serializable, and that's a totally reasonable thing to do. Happens all the time. Yeah.
Thank you.
You suggested that moving between MySQL and Postgres of some sort was an achievable task, and certainly when I did it, wasn't very achievable and involved an awful lot of hand coding the exporting. Have you got a clue on how I would move my MySQL databases to Postgres without killing myself?
Well, it depends on how Postgres centric or MySQL centric your database is. If you've written it in a largely pure Django way, you're probably going to be pretty okay. If you use a lot of MySQLisms, it can be more of a problem. And if you start using stored procedures, you're probably going to hire us or somebody like us. It's much easier going that way than the other way. Not that we encounter many people. Obviously there's a huge selection bias in a company like ours, but we don't encounter that many people who are going from Postgres to MySQL. If you're largely using the ORM and using sort of standard Django constructs, it's not too horrible. It's where you've written a lot of hand SQL. That's pretty horrible. And if you start using like MySQLisms, like the null foreign key thing, which I have to like my therapist to suggest that I not think about because it triggers me. Then you can be in trouble. So just move to Postgres and use lots of Postgres features, and you'll be so happy. Yes. Yes. Anything else?
Yes, I'm just wondering about GeoDjango and Serializable. You said there are problems with that, or there were issues?
It's lower performance. Because obviously Serializable had horrible performance. It had to do all this fancy lock checking and things like that. No one would use it. Generally, it performs very well. Gist and gin indexes, the locks that it has to take are heavier than they are on B-tree indexes, which if you are doing lots of writes to a gist or gin index in serializable mode can result in some blocking that may be less desirable. It works. I mean, the output will be exactly correct. The concurrency will not be as high performance as it would be in other circumstances. So don't panic, but you may want to just stick with repeatable read mode if you have especially a high write load PostGIS database.
So is there a speed slowdown by a factor?
There's no speed slowdown. There's a potential for blocking.
Okay.
Yeah, because what it does is it tries to lock the smallest granule, like down to the row level that it can. The problem is because the way gist and gin are implemented, it has to start locking pages or the whole index in some cases, which can cause concurrency trouble for multiple writers.
Thank you.
Sure.
Do you have any advice for the people who are using things that are Postgres compatible and run on Postgres but aren't normal Postgres? The people who have to do fun things like turn off save points or transactions completely in order to use the database, like PGXL or PGXC?
I don't have as much PGXC or XL experiences as I'd like. If you are, are you using it in production at this point?
It's on the exploration line for
Okay.
one of the roadmaps, and I discovered some fun facts about how Django works with it. So I wanted to see if you
Yeah, this is a little bit outside the strict rule of transactions. Is on things like XC, because this also applies to things like Redshift that are Postgres based but have like missing the insert statement like Redshift does. In those cases, you're better off sticking with kind of the lightest thing you possibly can. For example, XC doesn't even implement Serializable right now because it can't, the way that its distributed transaction manager works. It does implement repeatable read just fine for things like that. For save points, the only real danger is if you inherit code that expects to use them. It's really interesting because save points were a heavily used feature in Postgres until Exact and then Atomic came along, because now they became really super easy to use, and Django applications started to use them by default. So I'll be very interested to see what bugs we flesh out from save points, because we suddenly have this industry-wide test case for them. So I wish I had better advice other than, well, just can't use them then, which is kind of lame, but there it is. So. Yeah. But I would be interested in hearing about your XC experiences, definitely.
Look, over the past couple of months, someone called Afia has been doing something called Jepsen, where he's been testing a whole bunch of databases, and Postgres has come pretty much on top as far as, I guess, consistency. And Enterprise DB just recently talked about how it's outperforming MongoDB as a key store database. Is that something that's recommended outside of just saying that we're better than Mongo?
Well, I actually gave a talk in FOSDEM 2013 about using Postgres as a NoSQL database, which is a terrible term. It should be schemaless, but somehow the marketing people all adopted NoSQL, which is stupid, but there it is. So again, certain selection bias, given what I do for a living, but every test I have, the only way in which right now I'd say Mongo is significantly superior to Postgres is you can set is the right distributed clustering that Mongo can do. Very few installations really use that to the extent that they will notice a performance benefit out of it. And in just terms of raw performance, not only is Postgres faster, but then you get all the Postgres good stuff about this. Sadly, I mean, the MongoDB people are no fools, but Postgres has been working on these problems for 35 years, and MongoDB for much less than that. And a lot of these are just basic things that you have to get the code to a certain level of maturity. So in the sense of, yes, I do endorse EDB's results. I think they are they exactly align with my testing of Mongo versus Postgres. So
Thank you.
sure. Thank you very much.